All right, so this is section 2.2 linear equations. So we on section part one, we went over these problems here. All right, so I encourage you to review that if you haven't had a chance to look at part one. So now we are part two or day two of section 2.2. And this first question is asking us to determine whether the equation has no solutions, one solutions, or infinitely many solutions. Okay, so that has been the common theme in this section. So remember, when you're solving linear equations, you have to do the order of operations, PEMDAS, right? So please excuse my dear Aunt Sally. So that is the key to, and I'm going to rewrite it in this way. So parentheses trumps, then exponent, then whatever comes first, and that's why I put MD, whatever comes first, that's what you attack next. So the division comes first, then multiplication, that's fine. But again, they're on the same level. Same thing with addition and subtraction. All right. So whatever comes first from left to right regarding those. So I'm going to put DM or SA. Okay. All right. So here I'm attacking my parentheses, right? So x plus 3. I can't simplify that any further. So I need to what? Distribute. Okay. So I'm going to distribute the 5 in each for each of the terms. Okay. So that means I'm going to multiply. So we're going to get what? 5x plus 15 minus x equals 4x. Okay. All right. Then I'm going to combine like terms. So notice I have the 5x here and the minus x here. Okay. So I'm going to combine those. So 5x minus x is going to give me 4x plus 15. And then I have 4x on this side. Okay. So now again, I want to combine my x's together. So I'm going to subtract 4x on both sides. Okay. So I get 0 is equal to 15. Can we continue on here? No. Okay. Does this make any sense? No. So what does this mean? This is what? No solutions, right? Because there's 0 does not equal 15. That's not true. So again, remember behind the scenes what's happening. So in this case, these are two equations, and when you try to graph them, they'll never cross. So, all right. So they're probably parallel. And so that's why you'll have no solutions here because they'll never cross. So here we have no solutions for that one. All right, so in this one, right, again, I have to start with my parentheses. I can't simplify the inside the parentheses any longer. So now I need to distribute, multiply. So I'm going to multiply the 5 to each term. Then I have a minus 1, multiply to each term. Okay, so that gives me 10x plus 35 minus 10x minus 5 equals 30. Okay, and then I'm going to um, combine like terms. Okay, so I'm going to combine 10x with minus 10x. So that's going to give me 0. Okay, then I'm going to combine these guys together. 35 minus 5 is plus 30. All right, and that's equal to 30. So 0 plus 30 is 30. Hey, and that equals each other. Okay, so what does that mean? That means if the numbers are equal, they're what? You have infinitely many solutions. That means these two equations are the same equation. Okay, they are on top of each other. So in this one, we have infinitely many solutions. Okay, or you can just do the infinity symbol. All right, so for the last one here, what we want to do is, again, we want to focus on the parentheses, okay? We can't simplify that any further, so we need to distribute the -2 to each term there. So we get equals 15 minus 2x minus 14, okay? And then 5x on the left side. Then we're going to combine like terms on the right. So we got 15 minus 14 is going to give me 1 minus 2x. Okay. And then I'm going to add 2x to both sides because I'm solving for x. So 5x plus 2x is 7x equals 1. Okay. And then divide both sides by 7. So x gives me 1, 7. So that means I have one solution for the last problem. So graphically, what does this look like, right? So I have here, let me pause this for a second. Okay, so here I have wrote down the equations that we have. So for problem one is the first two, problem two is the second two equations, and then problem three is the third set. And I forgot to put my okay. So for the first one, we had 4x was equal to 5 times x plus 3 minus x, right? That was our first one. So notice when we graph them, they're parallel. So they never cross, okay? So that's why we had no solutions because they will never cross each other. If you look at our second problem, we had um, 5x is equal to, I'm sorry, 5 times 2x plus 7 minus 10x plus 5 equals 30. So these are these two problems here. Okay. 30 is way up there. All right. So when I graph them, what's happening? Let me pause for a second. So what happened? I'm looking for the other line, but the other line is what? It's the same thing, right? So y equals all this here is the same thing as y equals 30. It's the same line. So that's why we have infinitely many solutions. I was thinking I mistyped it or something. But anyway, they're the same thing. So that's why you'll get, see, green, and then you have the purple, right? So they're exactly the same equation. That's why they're just overlapping. Okay. And then the last one, we have 5x, all right? And again, we can zoom in here, but it's not a 0. But anyway, though that's our answer there. Okay. 0.1 divided by 7 is 0.14286. So anyway, so that's what it looks like graphically. All right. And that's how we got those answers. Okay, so before we attack this problem, let's do a problem that's going to prep us for this one. So let's say that we have Gold's Gym. Okay, Gold's Gym. All right. So for Gold's Gym, um, you have a starting costs of, let's say, $100. Okay. And then you have a monthly fee, okay, of say $50 a month. Okay. So in order to join Gold's Gym, right, because everything's made out of gold, you have to pay starting cost $100, and then you have a monthly fee of $50. Okay. So what we're dealing here is the slope intercept form. So remember the slope intercept form is equal to y is equal to mx plus b. Okay? Right? What was m again? Does anybody remember? Remember, that's the slope, right? Or rate, right? That's the slope or rate. What about the b? What does that mean again? That's the y-intercept, right? All right? Or starting point. Okay? It's so important that you understand what those two mean. Okay? All right. So in this case, again, if we're doing slope-intercept form, okay? So we're going to create our equation based off of this information. So that means we're going to focus on M and B. Okay? So in this case, what's going to be my M? What's my M in this case? $50, right? $50. That's my month. Slope is the same rate of change. You're getting charged $50 every single time, right? That's $50. So it's 50x. What's going to be my y-intercept or my b? $100, right? Because that's the starting fee, right? Starting point, starting fee. Okay? So this is my general equation. And so let's say month one, how much do I pay after 1 month? What's the total amount that I pay after 1 month? Total amount. 150, right? What is one? This is going to be equals x, right? So y is equal to 50 times 1 plus 100 gives me 150. Okay? All right. This gives me 150. Let's flip it out. Okay? 150. Right? How about the second month? How much do I pay the second month? Total. This is total. 200. Okay? So again, I put 2 in for x, right? So y is equal to 50 times 2 plus 100 will give me 200. Okay? So what about, say, month number 10? How much have I paid total after 10 months going to the gym? $600. Yes, right? Because we have y is equal to 50 times 100 plus, sorry, not 100, times 10 plus 100 will give me 500 plus 100 is $600. Okay? Make sense? All right. Any question there? Okay. So let's look at this one here. All right. Actually, let me do another problem real fast. Okay. Let's say you're mowing lawn. Mowing lawn. All right. You paid $500. Okay. So it costs you $500 to buy a mower. Okay? And so you have a lawn mowing business. Cost you 500 bucks. You bought this nice lawnmower. Okay? Then you're charging, let's say, $10 to mow the lawn, to mow each lawn. Okay? So you're going to charge $10 to mow a lawn. I'm just keeping it simple. To mow per lawn. All right? So if I have, again, we're going back to y is equal to mx plus b. Okay? And I always want to focus just on the m and the b here. What's going to be my m? What's my m? Good, 10, right? Hopefully you wrote down 10 because that's the how much you're charging per lawn. That's the rate, that's your slope. Okay, so $10, 10x. What's your b in this case? 500. Now, is this going to be a positive or a minus 500? Which one is it going to be? Is it going to be a positive or a minus 500? Minus. It's going to be minus, right? Why is it minus? Because you paid 500 bucks. You're down the whole $500. So you need to make that money back. That make sense? So I'm down the whole 500 bucks. So I need to put minus 500 instead of plus. Okay. Now I need to figure out, okay, how many, lawns do I need to mow in order to, you know, make up the money that I paid buying the lawnmower. Okay. So after mowing one lawn, right? If I mowed one lawn, okay, right? Now I will put 1 in for x, so that'd be 10 times 1 minus 500. Okay? So that will give me what? $490. Well, negative $490, right? Because I'm still down the hole. You with me? Okay? I'm still down the hole. If I mow two lawns total, I'll have 10 times 2 minus 500. So that'll give me what? Minus $480. Okay? So I can keep doing this, all right? Or what I can do, anyway, so um, I can, again, keep doing this until I can figure out how many lawns I need to uh, mow in order to make up the money that I had paid for buying the lawnmower. Okay? So how do we do that? Pause. So right now we're down the hole, right? So I want my outcome to be $0 so that, you know, I can start making money. Okay, so again, what I can do is, again, I can easily just take the 500 and divide it by 10. Okay, but if I were to write it as an equation, I can just set the y equal to 0. Okay, and then solve for x. Okay, so I can add 500 on both sides. Okay, and then the 500 will cancel. I have 500 on the left, and then divide both sides by 10. Okay, so x will give me 50. So that means then I have to mow 50 lawns in order to um, come out even. Okay. After I mow 50 lawns, then I can start making money. That's why in businesses, I'm so um, amazed by them because, like, for example, if you have a hair cutting business, right? And I remember this that going downtown, I got a haircut there. And the guy told me this was several years ago. He was paying like $1,400 a month to rent out that place, right? And back in the day, haircuts were not expensive now. So he was like charging $10 a haircut. So he would have had to, cut 140. If he was paying $1,400 a month and he was charging $10 a haircut, he would have to have cut 140 haircuts in order to come out even. After that, then, he can start making money. Of course, at the barber shop and things like that, they can sell other things. Like that's why you see them selling other things like shampoo or gel or anything like that because that's more money for them. Okay. Or tips, you give them a tip and stuff like that. So, but anyway, but I was like, man, you have to cut so many hairs just to come out even before you start making money. So, and it's like that for every business. So, in fact, here in this area, we had a Chinese place, and they went out of business because, again, they weren't selling enough in order to keep that location. So, which is unfortunate. All right, so let's go back to this problem. So, um, we have an athlete is 16 miles from home, running toward home at 6 miles per hour. Write an equation that calculates the distance d the athlete is from home after X hours. So what did we write there for part A? Excellent. So many of you are writing d is equal to 16 minus x, right? Because d is representing the distance from home and x is representing the hours. So for this case, A, right, our equation is d is equal to 16 minus 6x. Okay? How about for B? What's our answer for that? Exactly, right? So believe A and B help each other. So B will support your answer for A. So for this case, we want X to be 1.5 hours. So we just plug that in for X. So we get D is equal to 16 minus 1.5. Okay. 6 times 1.5 is 9. So it's going to give me 16 minus 9, which is going to give us 7 miles. Okay. So that's the distance away from home, right? And how about C? What's our answer for that one? So part B tells us that when X is 1.5 hours, D is going to equal 7 miles, right? Because we plugged in 1.5 hours for X. Okay. So um, the distance from home is 7 miles at 1.5 hours. But now in this case, instead of finding D, okay, we need to find X or C. Okay. It says find X when D is 5.5 miles. All right. So in this case, we're going to put 5.5 miles for D instead of X. Okay. So again, so we have D is equal to 16 minus 6x. They tell us, hey, what is D? Find X when D is 5.5. So that means I'm going to plug in 5.5 for D. okay? And then solve for x. You with me? Okay. So I'm going to subtract 16 on both sides. 5.5 minus 16 is negative 10.5. This will cancel. Minus 6x. Then I divide both sides by minus 6. Okay? So x in this case, when I put this in a calculator, remember negative divided by negative is a positive. So 10.5 divided by 6 will give me 1.75. Okay? So what is it saying? It's telling us that at a distance of 5.5 miles, he is 1.75 hours away. Okay? From home. So that's what it's saying. Okay?